Hello everyone, welcome to our video Helm chart deployment to Azure Kubernetes Service AKS. In this video, we will see a complete tutorial about Helm chart and how to use Helm to help you deploy and configure application for Azure Kubernetes Services. So we will get an overview about Helm charts, why to use Helm, how to use Helm, and many others. So first, we will get understand what is the Helm chart. I thought it's better to start with Helm chart instead of start with what is Helm. Because once we understand the Helm chart and then describing Helm, it will make more sense. After that, we will understand what is Helm and the definition of Helm, and then we will understand why to use Helm. And after that, we will understand how does Helm work. So we will understand the process in version 2 and version 3 and what is the difference between Helm version 2 and version 3, the major change in between version 2 and version 3, and how to use it. And then get some examples of Helm commands or switches, like for example, create, which generate the Helm charts or template, and then install, which install the application on Kubernetes, and then repo add, which is add a community repo for the Helm, and then searching for searching a pre-configured Helm charts. And then we will go for the demo. In the demo, first, we will start by configuring the prerequisite, which is first install Azure CLI and then install Windows Package Management, Chocolatey. This will be used to install the Helm, so I can install Helm CLI as a client on my machine, and then provision Azure Container Registry or ACR on Azure, and then provision Azure Kubernetes Service or AKS on Azure, and then git clone for a sample application, Node.js application from GitHub on a Microsoft sample application, and then building a Docker image for the Node.js and push that image to the ACR or Azure Container Registry, and then generate the Helm chart using the Helm command, and then update this chart with my values that including where is my image and where is my Azure Container Registry and so on. And after that, execute the Helm charts to send that to the Azure Kubernetes service to deploy my application to the Kubernetes. But first, let me give you a quick introduction about myself. My name is Mohammed Radwan. I'm a developer technologies MVP and principal DevOps consultant. I have been doing software development for more than 17 years now. Worked on several projects for different enterprise customers across different regions and countries. I heavily participated in the community, developed several frameworks, presented many sessions, holding various certificates for Azure and DevOps. I started back in 2002 as a classic ASP developer, relocated multiple times in multiple countries, worked with several technologies and for different roles and positions. And for the last 8 years, I moved to consultancy-based role where I focused more on helping different companies, some of them from the Fortune 500, to improve their software development and delivery using DevOps and automation. I have developed and authored several frameworks, command line tools, and guides. You can find them on GitHub and Azure DevOps Marketplace. I have presented many sessions in several user group conferences, events, and customer site as well in different countries. So I got the chance and the opportunity to work in different culture, project size, and company size as well, which helped me to have different experience. I like to share my experience. This is why I have a YouTube channel and blog where they have hundreds of videos and posts that share different topics from my real experience. Here are some links for my activities. What is Helm chart? Helm chart, this is just like a bunch of files. We can say that it is a package of files that will be used to deploy application to Kubernetes. So it's just a bunch of files that has all the information to deploy the application to Kubernetes. So it consists of the first is the chart.yaml, and this including the metadata for the chart, including, for example, what is the version of this chart, like, because again, it's a package management. So, you have different version. Every time you deploy your application to Kubernetes, it's just incrementing the version. And the chart here, including the version of the application you are going to deploy to the Kubernetes. So the chart is the metadata for the complete chart or the application. And then the values. The values here, this is just including the values for the template. The main idea of Helm chart is just a bunch of template that I can inject the values in this template on the runtime. And the values.yaml file is the file where I put the values to be injected in the templates. And then we have the directory or the folder which called templates. And inside this templates, I have the deployment YAML. This is the normal deployment that we use to deploy deployment or services to the Kubernetes. But in this case, we don't have the value directly in the file. We just have a variable, and this variable will has the value inside the values.yaml in the chart. I have also the services YAML, I have helpers, which include some predefined functions where I can use to concatenate some values and so on. I can even create my own functions inside this helper in the Helm charts, which will be recognized by Helm tool, so it can interpret my function or the built-in function to change that values. So this is the Helm chart. As we now understand the Helm chart, let's understand what is Helm. So Helm is a tool that uses package management to enable creating, installing, and managing application inside Kubernetes much easier, configurable, and repeatable. This is the main idea. So it's just a tool with the package management configuration that help me to make managing Kubernetes application is much easier, configurable, and repeatable. So why to use Helm? Just imagine, again, by using Helm, it means that I can search for pre-configured or pre-packaged, which is we call charts. Let's say, for example, I want to deploy an application with MongoDB, Node.js, so I can search for any Helm repo for a similar charts, and then just to download this chart, just to change some of the values and then use it. So pre-packaged charts, and then I can find them. Also, I can easily create my own package, which is bunch of files, and then using these files, I can store them on the package management. Again, storing them maybe in Git or any repository where I can redistribute them, deploy the application to Kubernetes. So it is the same idea. I can search for pre-package or I can create my own package. Also, I can install packages into Kubernetes cluster. This is the main functionality of Helm, to use the packages to install application to Kubernetes cluster. Also, I can query cluster to see what package are installed and running. For example, if I want to see what is the version of my chart that installed on the Kubernetes now, so I can query that. Let's say, for example, it's version 2 or version 3, version 4. So it's very easy to query to understand what is the current version of my package on the Kubernetes. Also, I can delete, rollback. This is one of the very important feature of Helm, which means I can roll back to a previous version. Let's say, for example, that I deploy a chart version 2, and then it has some error, and then I need to roll back to version 1. So this history is stored on the Helm, so I can roll back to version 1. And this is the main idea of having Helm, is the easy of rollback to a previous version. So Helm makes it easy to run application inside Kubernetes. This is the main idea of using Helm. So let's see how does Helm work. So if I start with Helm version 2, because there is major change between version 2 and version 3. With Helm version 2, we have the client CLI that we installed on our client machine. And then we have the server, which is Tiller on the Kubernetes side. And then here I have the Helm chart either on my client machine or maybe on a remote repository. And then I will send the request with this Helm chart to the server or the Tiller. And this server will start executing this chart to create the deployment, the service, the pods, etc. of the Kubernetes. So it will just interpret the charts and inject the values in the chart file into the deployment YAML and so on. So it will be executed in the runtime to be understood by Kubernetes, so it can create the deployment and services, pods, and so on. So this is in version 2. In version 3, what is the main difference? There is some concern about security and how Tiller is having really huge security concerns about the ability to create many things. This is why in Helm version 3, they remove Tiller. And instead, they're using the Kubernetes APIs for the same capabilities. So it still can store the previous deployment, and so you can roll back and so on. And this is the main difference or the major change between version 2 and version 3. Some example of Helm commands. We have the create switch or command with Helm, which will generate the charts or the template for me, where I can just changing that with my own values. I can also use install switch, which will send the requests to the Helm server or the Kubernetes APIs in the version 3, for example, so it can create the charts, execute the charts, and create what inside the charts, which is the application, the deployment, the services, the pods, and so on. Repo add, if I want to add a repo to my Helm, so for example, let's say I add a repo 1 in the community, and then I can search this repo for a pre-configured charts where I can just search and then download and then just changing that to the way that is suitable for me. Search, where I can search the added repo in, and there is many other commands. So let's go for the demo. So first, let's navigate to the command line and open it in elevated mode as an administrator. So if we type easy, which is Azure CLI or command line interface, we can see that we don't have Azure CLI. So the first step is to install Azure CLI. And in order to do that, I will just open the URL that I can download Azure CLI for Windows. Now it download and then just accept and install. Once this completed, now it's completed, just close this, minimize. And if I type easy, of course it will not work because it's not loaded. So I just need to open a new window. Let's close the old one and type easy. So now we can see Azure CLI is installed. Let's now install Helm. But to install Helm, I just need to install Chocolatey first. And Chocolatey is a package management for Windows. So if I type Choco, we can see it is not installed. And in order to install that, I just need to open Chocolatey website and just copy this command here in the CMD. Just now it's completed. If I type Choco, we can see now it's installed. Then I can install Helm. If I type Helm, we can see that it's not installed. So if I type Choco install Kubernetes -Helm, this will install Helm client. Put A for all, and then just give. Now if I type Helm, we can see that now Helm is installed. Okay, so now I have all the prerequisites installed. So let's close that, and this is my Azure subscription. I just have 2 resource group, and then I'm going to create a new resource group. Okay, so here I will start by typing first login, so I can log in from the command line, so I can have enough permission. I can close this windows, and now as we can see I'm logged. The first command is to create a resource group, and I will name my resource group is AKS resource group, and the location is UK South. Here again, just to refresh to show you here, I don't have this resource group. then just type enter. Now if I refresh again, now I have my resource group, and it is an empty resource group. So the next step is to just create Azure Container Registry. So here I will specify which resource group I want to create, and then the name of the Azure Container Registry and the SKU, which is basic in our case. And then just type enter. Now it's created. Just get back to my resource group, just refresh, wait for some time and refresh. Now it's created, as we can see. If I navigate to the repositories, we can see it's empty. It doesn't include any images. Then let's navigate back to our resource group. And the next step is to start create Azure Kubernetes Services, or AKS. And in this command, I will just give my resource group, which is AKS resource group, RG, and the name of my Azure Kubernetes Services, which in this case, my AKS, the location, which will be UK South, and I will attach the ACR. This attachment switch will make sure to get the permission between the AKS and Azure Container Registry, or ACR, and then here to generate the SSH key, which will be used to this authentication. Just hit enter. Now the service principal created, and it will start creating the AKS. Now it's completed. Let's get back here and refresh. Of course, it will take some time. And here my AKS created. So let's navigate back to the command line. If I type kubectl, which is the command line tool for work with Kubernetes, we can see it is not installed. So in order to install that, I will use AKS install CLI, which will install the kubectl for Azure CLI. So now it's installed. So I just need to take this path. Of course, this is an Azure version of kubectl. And then here I just go for the environment variable, and in the path, just edit and add a new value with the current path of kubectl. So let's navigate to this path so we can see the tool. So as we can see, this is the kubectl. Now it's okay. And again, if I type kubectl, yes, it's not recognized because this is an old window. Let's open a new one. And if I type kubectl, we can see now it's installed. So what I'm going to do now is to get the permission for kubectl to communicate with the AKS. To use kubectl to run a command that can access the AKS, or Azure Kubernetes Service, I need to get the permission from kubectl to the AKS. And in order to do that, I will use this command line, which will get the credentials for this is the name of the resource group and the name of my Azure Kubernetes Services, and get credentials command. So this will generate the credentials and store that credentials in this path. So let's navigate to see that. So if I copy that and let's navigate to this location, we don't need the config, this is the file. So we can see this is the config file. And if I open that, we can see here, I have here the name of my AKS, which is the Azure Kubernetes Service. And here also I have the client certificates, which will be used to authenticate from the command line to the Azure Kubernetes Services on Azure. Okay, let's close that. So now I can run command from kubectl to my AKS. Now, let's use a sample application that we can deploy to the AKS using Helm. So in order to do that, I will navigate to a GitHub sample application that's created by Microsoft. And if we go navigate to the Node.js here, web front end. This is a sample application I will use. So in order, I just need to use git to clone that. But first I need to check that git installed on my machine. And as we can see, it is not installed. So I will use Choco or Chocolatey to install git, and just type Choco install git. So this will install git on my local machine. Just confirm all. And now I just type git. Of course, it's not loaded. Let's open a new window and type git. So as we can see, git is installed. So let's now clone the repo that I showed you before. So git clone the URL of the repo. Now the repo is cloned, and let's navigate to the application I showed you, which is the web front end, Node.js. And here in the getting start and web front end, just navigate to the location of the app. And if I just copy that here to see the cloned repo on my machine, we can see that it's just here. Yes, so inside web front end. So now I will just create a new file to make a Docker file. And inside that, I will type this command, which will pull the last node image from a Docker hub, and then copy my web front end, this sample application, to this image, and copy the JSON file, and then run node package management install, copy everything, and expose port 80. So, and just save this as a Docker file without any extension. Docker file. Just close that, and I don't need the text. I just need the Docker file. Let's review that to make sure the code is exist. Yes, just to close that. So now I have my Docker file. And then the next step is to just navigate. Let's navigate to the Azure Container Registry, to repositories. As we can see, it's empty. So the next step is to just create or build an image from the Docker file and push this image to Azure Container Registry. So in order to do that, I will just type this command, which will build the image, and the name will be web front end version 1. And this is the registry or Azure Container Registry, and this is the Docker file. So this will build the image and push the image to the Azure Container Registry. It will take some time. Of course, I speed up all the process. Now it's completed. If I navigate back here, refresh, we can see now that I have the image. Now, if I get back here to just run kubectl git pods, because we don't deploy any pods yet, we don't have anything, then this will show me that no resources found for the default namespace. There is no pods created yet in my Azure Kubernetes Services. Okay, so now I'm going to navigate here. This is the place, the directory, and I will start to create a Helm chart. In order to do that, I will use Helm Create web front end. So Create will just create a templates or a chart for me using Helm charts. So once I run this command, just look, as you can see, this directory created, including all the file of Helm chart. So for example, I can go for the templates, which include all the templates. This is the deployment YAML, including all the variables. So I can just use it as it is or just modify it. And here, this is the ingress YAML. All of these generated from the create command. This is the service YAML. So this is just as a template, as we can see. And the most important file is the chart and the values. So let's open the chart. So we will change the version. Of course, with every change I made to the Helm chart and values, I should increment the version in that chart file. So for example here, because this is the first one, so I will just version that as version 1 and it use semantic version, by the way. And then here I will go for the values, edit that. So what I'm going to change here, this is the place where I have my image or my Docker image. So I will here just get the address of my Azure Container Registry. This is the address, login server, and forward by the name of the image, which is web front end. And then instead of cluster IP in the service, I will choose to be load balancer. Now I will just save these values. So now I'm ready to run Helm install. So what I'm going to do now is just run kubectl get service watch before run Helm install so I can see what I have in my AKS. So if I run now, we can see that I just have Kubernetes cluster IP, and this is the internal IP. And now if I run Helm install web front end and web front end, this is the name of the chart, and using the chart template after I change all the changes, install command of Helm will just run the charts and the values in the charts to start pushing and creating the pods and the services, the deployment, and push the image to the Azure Kubernetes Services. So just hit enter and let's go for watch again so we can see. If I watch now, we can see now I have the load balancer and it is bending. This is the web front end. And now it has an IP, external IP, but it will take a little bit to push that. Let's open a new window. And if I just type here kubectl get pods, so we can see the actual pods, we can see now I have one pod, which is web front end, and it's running, but still not ready yet. So just wait to be ready. And also, while this, let's close this one, open a new command line in elevated mode as well. And now I'm going to browse to the Kubernetes dashboard. But in order to do that, I just need to give the permission to the cluster user. And in order to do that, I will just delete the cluster binding. Let's delete it. First, get the pods. It's ready now, as we can see. And then just here, I will delete the cluster binding. Now it's deleted and start creating again with, as we can see here, this is the user cluster user, this is the user I will use to open the dashboard of Kubernetes. In some cases, it will just show you that the user already exists. If this is the case, you just delete it again 2 times this time. Yes, deleted and delete it again. And then create the role binding. Now it's created. It doesn't give me the error as user already exists. And now let's browse to the dashboard of the Kubernetes. This will open a proxy tunnel. Now it asks me for authentication. I will use the config file that I created when I get credentials, which create the config file on my machine. So I will use the config. Remember this step and then sign in here. So once I sign, I can see the pods, the deployments, the replica set, and all the component of the Kubernetes. Let's navigate back here to the AKS. So we can see here, this is the public or the external IP. So if I copy that, let's got here. So as we can see, it must be ready. So navigate that to here in a new tab. We can see now the application, which is a sample Node.js application, is loaded successfully on running on AKS or Azure Kubernetes Service. And if I click on this button, it just say that. At the end, I would like to thank you for watching the video. Please, if you have any question or comment, don't hesitate to reach out. You can find more information on my blog, which will appear at the end of the video, along with some other related video. Thank you.